Hello friends, welcome to our channel. I hope you are all in a very good health and doing well with your studies. Thank you for joining me. Today we are going to solve some numericals related to mirror formula and linear magnification. So we have two questions that we are going to solve now. The first question says calculate the distance of an object of height h from a concave mirror with radius of curvature 20 cm so as to obtain a real image of magnification 2. Find the location of the image. So this is what our question says. Now let us do it. So radius of curvature, question number 1, 2. So solution. Radius of curvature is given. So for a concave mirror, we take the radius of curvature negative. So the radius of curvature is minus 20 centimeter. Therefore, the focal length is half of radius of curvature. That means minus 10 centimeter. Now friends, if we look at the next part of this question, it says um, so as to obtain a real image of magnification 2. So the formula for magnification we know is m equal to minus v by u, and for a real image we take magnification negative. So it is equal to minus 2. For real image we write magnification negative. So m is equal to minus v by u is equal to 2. So we can say, or v should be equal to 2 into u. So the so the image distance is twice of the object distance. The image distance is twice that of the object distance. Now we need to find the location of the image. So our first question is calculate the distance of an object. We are going to find the object distance first. After that we are going to find out the image distance. So we have these informations. Now if we apply mirror formula we can write 1 by f is equal to 1 by u plus 1 by v. So in place of f we can write minus 10. In place of u we can write 1 by u. In place of v we can write 2u. So the LCM becomes 2u. So 2 plus 1, that means 3 by 2u. So 1 minus 1 by 10 is equal to 3 by 2u, or we can say minus 2u is equal to 30, or u should be equal to minus 15 centimeter. So this is the answer of first part. Okay, this is our object distance. Now we need the answer of the second part. Find the location of the image also. So we need v. So if in this relation we put the value of u, we can say v is equal to 2 into, in place of u we can write minus 15. So minus 30 centimeter. So the image distance from the pole is minus 30 centimeter. So this is the solution, friends. I hope you have understood it. Now friends, let us proceed to the next question. The next question says, when an object is placed at a distance of 60 centimeter from a convex mirror, the magnification produced is half. So the object distance is given 60 centimeter and the mirror is a convex mirror. The magnification is half. So our question is, where should the object be placed to get a magnification of 1/3? This is our question. So let us do it. Question number 2. Solution. U is given, and for a convex mirror object distance is negative. So object distance is given, which is minus 60 centimeter, and the magnification is given. We know the formula for magnification is m equal to minus v by u, but for a convex mirror we get a virtual image, and for a virtual image the magnification is always taken positive, so it is equal to half. Okay, so for a real image the magnification is taken negative, and for a virtual image we take magnification positive. So minus v by u should be equal to half, or we can say minus v by u, that means minus 60, is equal to half, or minus minus can be cancelled, so it becomes v is equal to 60 by 2, so it is equal to 30 centimeter. Okay, positive 30. So we can say the image distance is 30 centimeter, and it is formed behind the mirror. Now we know v, so we can easily find out the focal length of the mirror. So therefore we need to find f of the convex mirror. Now we need to find out focal length of the mirror. So by mirror formula we can write 1 by f is equal to 1 by u plus 1 by v. U is equal to minus 60 and v is equal to plus 30. So the LCM becomes 60. It is minus 1 plus 2. So it is 1 by 60. So the focal length we can say it is 60 centimeter, which is positive. So the focal length is 60 centimeter. And now we can come to the second part of the question. The focal length of the mirror is never changed. Okay, the focal length is fixed. Now we can come to the second part of the question, which says where should the object be placed to get a magnification of 1/3. Okay, so now to get a magnification of 1/3. So from the formula of magnification we can write this is minus v by u, and and the magnification is taken positive for a convex mirror. So from this relation we can write um, v equal to minus u by 3. Okay friends, now if we apply the mirror formula we can say 1 by f is equal to 1 by u plus 1 by v. Now the focal length is unchanged, which is 60 positive, and 1 by u is kept as it is, and in place of v we can write minus u by 3. So it becomes 1 by u minus 3 by u, which gives us 1 minus 3, that means minus 2. So this is what we are getting. 1 by 60 is equal to minus 2 by u. So u is equal to minus 120. So the object should be placed in front of the mirror at a distance of 120 centimeter from the pole. Okay, to get a magnification of 1/3. I hope you have understood it very well. Thank you, friends. So, this is our question, which says an object is placed exactly midway between concave and convex mirror. The radius of curvature of first mirror is 50 centimeter. Radius of curvature of second mirror is 40 centimeter. The mirrors face each other at the mirrors face each other and are 60 centimeter apart. Determine the nature and position of image formed by successive reflections, first at concave and then at convex mirror. So let us draw the diagram. So let us assume this is our concave mirror and this is our convex mirror. Okay, this is concave, this is convex, this is the principal axis, this is our pole 1, this is pole 2. The object is placed somewhere in between these two mirrors. Uh, the object is placed exactly at the midpoint of the line joining these two mirrors. So this distance, the distance between P1 and P2 should be, it is given, the mirrors are 60 centimeter apart. This is 60 centimeter. So this distance where the object is placed, this distance should be 30 centimeter. This is our object AB. For the concave mirror, the radius of curvature is 50 centimeter. So let us assume this is the focus and this is our radius of curve. This is focus and this is center of curvature for the concave mirror. So we can assume two rays of light are coming out of this object from any point. Let us assume from point A. The first ray is parallel to the principal axis. So after getting reflected, it passes through the focus and strikes the convex mirror. And let us assume another ray from point A is coming out and after getting reflected by the concave mirror, it passes through the center of curvature. Now When the rays strike the second mirror, they will again get reflected. Now, if we draw the image formed by the concave mirror, this is our image. So, the rays reflected by the concave mirror forms a real image. If we ignore the convex mirror for a moment, okay, if we ignore the second reflection and the convex mirror for some time, then the reflected rays coming, if we ignore the second mirror and the second reflection, then we can say the rays coming out of point A after getting reflected at the mirror 1, that means by the concave mirror, they will meet at a point where a real image will be formed. This is our real image. If we ignore the second mirror and the second reflection for some time. Now, let us consider the second mirror, that means the convex mirror. So, if we place a convex mirror, these rays will again get reflected. And the image, that means A dashed B dashed, the real image of the object AB formed by the reflection from the concave mirror acts as a virtual object for the second mirror. Okay, so the first image, that means the real image, is acting as a virtual object for the second mirror. So the image of A dashed B dashed will be formed if we drag this rays backwards, if we drag this rays backwards, they will meet at a point and form a virtual image A dashed, A double dashed, B double dashed. So, when an object is placed in front of a concave mirror, a real image is formed of that object. And now, if we place a convex mirror so when we put an object in front of a concave mirror, we get a real image of that object. So A dashed B dashed is the real image of AB. So if we consider only the reflection by the concave mirror, we can say this is our object distance and this is our image distance. Thirty centimeter is our object distance and this is our image distance for the reflection by the concave mirror. We do not know this. We have to find out it. Now, if we put a convex mirror at a distance which is shorter than the distance of A dashed B dashed, then these rays, the rays reflected by the concave mirror, will again get reflected by the convex mirror. Now, if we put a convex mirror we will get another reflection. For the second reflection, that is the reflection from the convex mirror, A dashed B dashed will be a virtual object. This will behave like an object, a virtual object. and another image will be formed. If we produce these reflected rays backwards, they will meet at a point and we will get a virtual image of this a dashed b dashed. So a double dashed b dashed is the image of a dashed b dashed. This is our virtual object, virtual image. Okay. So a dashed b dashed, which is actually an image, but it can act as a virtual object and produce another image. So this is what the diagram says. Now, if we look at the question, we need to determine the nature and position of image formed by the successive reflections. First at the concave mirror, okay? So we have to talk about this image, the nature and position of this image. So we can easily say that for the concave mirror, if we apply the mirror formula, we can say 1 by f is, this is our focal length, which is half of the radius of curvature. That means 25 centimeter minus 25 centimeter. So the focal length of the concave mirror is this, minus 25 centimeter. Object distance, it is minus 30. U is minus 30. So it gives us 150, the LCM. So the object distance is, okay, we can name it, because it is the first mirror, we can name it F1, U1, V1. So V1 is minus 150 centimeter. So the minus sign tells us that the image is a real image, and the image distance, the image is formed in front of the concave mirror. At a distance 150 centimeter. So this is about our real image, our first image formed by the concave mirror. Now we shall talk about the image formed by the convex mirror. For the convex mirror, we can say, if we apply the mirror formula, 1 by f2 is equal to 1 by u2 is equal plus 1 by v2. So we can say 1 by v2 is equal to 1 by f2 minus 1 by u2. So we can find out the focal length because radius of curvature is 40. So the focal length will be 20 centimeter, and for a convex mirror the focal length is taken positive. So it is 20 minus 1 by u2. So this is our virtual object. Now the first image acts as the virtual object. So the object distance will be this is 150 and this is 60. So 150 minus 60. Okay, this is our object distance for the second reflection. Okay, this is our object distance. This object distance is 150 centimeter minus this is our 150 centimeter. 150 centimeter minus 60 centimeter. So this is our object distance. Okay, 150 minus 60, that means 90. For a convex mirror, object distance so this is 1 by 20 minus 1 by 90. This is our 1 by v2. The object distance is measured in the direction of light. Okay, so when we are measuring this object distance, it is measured in the direction of light, so it is taken positive. This distance is positive 90, 1 by 90, and the focal length when it is measured, it is also measured in the direction of light, so it is 1 by 20. So if we simplify it, we get 180. 180 and 20. When we divide 180 by 20, we get 9. When we divide 180 by 90, we get 2. So this is our 1 by V2. This is 7 by 180. This is our 1 by V2. So V2 is 180 by 7 centimeter. Okay, and this is positive. That means the image formed, we can say, okay, for the convex mirror, we can say image formed because the image distance is positive. So from this conclusion, so from this result, we can conclude that the image formed is virtual and it is formed behind the mirror at a distance 180 by 7 centimeter. So I hope this question is clear to you. Thank you.